Today we're going to be looking at how to solve quadratic equations by completing the square. So we've learned how to solve them by graphing them and then using our calculator to figure out where it crosses the x-axis. We've learned how to solve them by factoring them and then setting the different factored parentheses equal to 0. So today we're going to learn how to do it by hand without graphing and without factoring, because sometimes you just can't factor equations. Like this example that says to solve 4x squared plus 12x minus 9, that is not factorable. If we tried to do it with our little x method, we'd get negative 36 on top because we're multiplying the first and the last together, and then we'd put 12 in the bottom. And there are no factors of negative 36 that will add to 12. A lot of people say, well, what about negative 6 and negative 6? Well, negative 6 and negative 6 multiply to positive 36 and they add to negative 12. And a positive 6 and 6 would add to a positive 12, but they would multiply to a positive 36, so that doesn't work. So, what we are going to do instead is do this process called completing the square. Basically, what it's trying to do is get it so that one side of the equation factors into a perfect square, kind of like how we were factoring a sum of squares a couple days ago on that third worksheet for factoring. And that way, when we try to solve for x, we can take this square root and get rid of that squared and just have an equation with a single x in it. So let's go ahead and follow these steps on the right side of the screen. So our first step is to move c to the other side of the equation. Now when I talk about a, b, and c, or when the book talks about those, you want to remember that the quadratics are in the form ax squared plus bx plus c equals 0 or equals y, depending on if you're graphing it or solving it. So when we move c to the other side of the equation on our example, c in this case is 9. So we'll add 9 to both sides and get 4x squared plus 12x equals 9. Okay, I'm going to leave a blank space between the 12x and the equal sign just for now, because we're going to be adding something there in a minute. Okay, the next step is to factor a out on one side if a is not equal to just positive 1. Because if it's equal to positive 1, that's not really going to change anything. That just means we can skip that step. In our case, we have 4 on in our a spot on the left side, so we'll factor out a 4. Okay, so that makes it so that our new a value is 1. So when we factor a 4 out of 12, that will give us just a 3x. Again, I'm leaving a blank space, and that's still equal to 9. We are only factoring a out on the left side. And we're not factoring out an x, and you'll see why in just a second, because we need a quadratic expression to factor into a square. Alright, now we're going to take our new b value, which in this case is 3. We're going to divide it by 2 and square it. So that's just some random calculations. I'm going to do this in maybe this blank spot over here. So 3 over 2 squared. And I'm going to leave that as a fraction, okay, because that's going to make it a little simpler later. So 3 over 2 is 1.5. And then when we square that, the 3 squared is 9, and the 2 squared is 4. Okay? So that value is important. In step 4, we're going to add that to both sides. So I'm going to add it inside the parentheses here, and I'm going to add it to the other side of the equation as well. However, you want to be very careful on this step. I am not just adding 9/4 to the other side. Nope. Because if you look at our equation, we really added 9/4 times 4. Okay? So you want to make sure that we add the exact same thing to both sides. So we have to add 4 times 9/4 to the other side as well. So let's add 4 times 9/4 to the other side. Now in this case, that's nice because 4 over 4 just cancels, and really we're adding 9 to the other side. So that'll simplify our fractions a little bit. Okay, next step, step 5, we are going to be factoring one side to a perfect square. Now that should be the side with the x's in it. So we're going to keep our 4 here, And we know that this should factor into x plus something or minus something squared. Now you can either use your x method to figure out what factors of 9/4 will add to 3. This one's a little harder to do that because it's a fraction. So there's actually a shortcut you can use, and that is written down right here in step 5. So that's going to always factor into the x plus the number that we got when we took b over 2 before we squared it. So in this case it'll be 3/2. So that'll be x plus 3/2 squared. It's going to equal our 9 plus 9, which is going to be 18. Okay, now if you want to check that and FOIL it back together, you will get x squared plus 3x plus 9/2. And when we double check our factoring, two numbers that multiply to 9/4 and add to 3, that is 3/2, because 3 over 2 times 3 over 2 gives us the 9 over 4, and 3/2 plus 3/2 is 6/2, and 6/2 is 3. So that factor is fine. And on your homework you shouldn't really have any of these fraction things. I just made this problem up, so that's why it's a little messy. Okay, so then we are just going to solve for x. So we're going to use our algebra skills that we've learned so far to try to get x by itself. So the first thing I might do is divide both sides by that 4, so that we have just a parenthesis on one side. So the 4's will cancel on the left. We have x plus 3/2 squared on that side equals, let's see, 18/4 reduces to 9/2. Man, yeah, this problem is kind of messy, but it shouldn't be this messy on your homework. You might get messy answers, but that's okay. The process should be fairly simple. So then, to get rid of the square, this is the whole reason why we completed the square, so we can take the square root of both sides. And the square root of a square cancels. So we will just have x plus 3/2 on the left side. And let's see, the square root of 9 is 3. We don't know the square root of 2, or we don't have that decimal memorized. And in fact, we don't want to put it as a decimal because that wouldn't be an exact answer. And we need to remember that it's plus or minus. Okay, whenever we take the square root, it's always plus or minus. So then we can just subtract both sides by 3/2 to solve for x. So if we take that over here, we'll get x equals, and then I'm going to put the negative 3/2 first, plus or minus 3 over square root of 2. Which that's kind of, it's kind of bad manners in math to leave a square root on the bottom of a fraction. And we haven't learned how to do this yet, but to change that, that's called rationalizing the denominator. And all you have to do is just multiply the top and the bottom by the square root of the bottom. That'll make it so that the square root's in the top instead. So what that gives, and you won't have to do that on your homework. Again, this is just messy because I made up this problem. So negative 3/2 plus or minus 3 square roots of 2 over 2 times square root of 2 times square root of 2 is 2. Okay, so that is your answer, and we would obviously not get that if we tried to factor it. And if we tried to do it on our calculator and graph it, we would end up getting the decimal. We wouldn't really be able to figure out the exact answer. So that's why completing the square is useful. Okay, so let's say that, like the last two problems on your homework, you want to try to get this in vertex form. So if you remember from when we were graphing, vertex form for a quadratic looks something like this. You've got x minus h squared plus k. So really you just want to complete the square on the problem and then move everything back to the right side so that we have something squared. So if we take our problem from just the last example, we just do the same methods that we did. So if we look over at our work, we would end up getting, let's see, right here is where we were at. So 4 times x plus 3/2 squared equals 18. So only in this case that would be equal to not 0 but y. You know, actually, let's make an easier example. So let's say y equals x squared plus 3x plus 7. Okay, let's say we want to put that in vertex form. So we follow the same steps, we subtract c to the other side, so in this case we'll just have y equals -7, or y minus 7 equals x squared plus 3x. We factor out a, which in this case is 1, so really we don't have to factor out anything. Oh man, again I did a fraction thing. Oh well, so we take b over 2 and square it, and that gives us 9/4. So we add 9/4 to both sides. That's just a separate little work right there. Okay, so let's see, -7, if we times that by 4, that is -28. So that's 28/4 plus 9/4 equals our x squared plus 3x plus 9/4. Alright, so we have y minus -28 and 9 is -19/4. And then the right side should factor into a perfect square, which it does. So x plus 3/2 squared. Again, you shouldn't get fractions like that in your homework. I just made that up, so it's a little messy. And so when we add the c back over, so in this case you would move c back to the right side instead of trying to solve for x, because we want an equation to graph. So you get y equals x plus 3/2 squared plus 19/4. So that would be your vertex form, and then to graph it, you know, your vertex will be -3/2, comma 19/4. And then, you know, you just graph it. It's going to smile. It'll look something like that. Okay. Alright, that should be it. If you have questions, you can look in section 3.5 of your textbook. That also explains completing the square. And the key should be on the counter.